Good morning, students of Algebra 1. We will be continuing week 2, e-learning, and the topic this week is factoring. So we've already done factoring, so this will be a review. And how did we start out last time? It was with finding the GCF, or the greatest common factor. So first of all, what are factors? Well, let's say I had the number 8, and I said, what are the factors of 8? So what numbers divide evenly into an 8? We have a 1, 2, 4, 5 no, 6 no, 7 no, 8. So all these numbers divide evenly into a 16. Now let's say I had into an 8. What if I had a 16? What are factors of 16? 1, 2, 4, 8, and 16. So if I want the greatest, I'm looking for the biggest one. Common means they both have it in common. So what's the biggest number you see that they both have in common? So it looks like it's going to be the 8. So this is one way of finding the GCF. But you notice, if I asked you, why could the GCF not be that 16? Well, the answer is, this is 8, so the highest factor of an 8 would be an 8 itself. So when you're looking for a GCF, the easiest way to do it is just to write the factors of the smaller one, and then it's either got to be that number or something smaller. It can't be a 16 because there's no 16 over here. So how about if I had, let's say, 8 and 12? Well, I'm going to list all the factors of 8, so just like before, 1, 2, 4, and 8. And I'm going to save some time. I'm not even going to list the factors of 12. I'm just going to ask myself questions. I'm going to say, I'll start with the biggest one, because I want the greatest, so let's see if the biggest one, the greatest one, fits into a 12. Does 8 divide evenly into a 12? In other words, is 8 a factor of 12? No. So that's not the GCF. And I go down the list. How about a 4? Does a 4 fit into a 12? Yes. So there's an easy way to find the GCF. You start with the smaller number of the two, or there might be more than that, but you start with the smallest one, list the factors, and then you start going down. Try to get the biggest one if you can, because we want the greatest, and then work your way down. And then what if we have variables? So if I said I had x cubed and x to the 5th, what are the factors of x cubed? Well, isn't that just x times x times x? X to the 5th would be 1, 2, 3, 4, 5. So when I'm looking for the GCF, I'm trying to take as many of these x's out as I can. In other words, what do they both have in common? Well, this guy's got 3. Does this guy got 3? Yeah, he's got 5. Now someone's going to say, well, can't I take out 5 x's? I mean, I want to take out as many as I can. The only problem is he doesn't have 5. So what's the most amount of x's that I can take out that they both have? Well, it's the 3, because this guy also has 3. So if I said, what's the GCF of x cubed and x to the 5th? The GCF would be x to the 3rd. So when you're dealing with variables, the easiest way to think about it is it's always going to be the smaller of the exponents. So let's see some examples here. So I've got two terms, and I say, what is the GCF? We always start with the coefficients first. So this is a 5 and a 20. So start with the smaller number. What are the factors of 5? Well, 5, 1, and 5, right? So start with the biggest one. Does 5 fit into a 20? Yes. So that's your GCF for 5 and 20. Now he's got 1x. Does he have any x's? No. So the rule is, I'm trying to take out factors, but they both got to have it. So he's got an x, but he doesn't, so I can't take any x's out. So what's the GCF of these two terms? 5. But now if I want to factor, it's basically like multiplying in reverse. So 5 times what mystery term makes 5x? Well, what's missing? I already got the 5, but I need the x. 5 times what makes a positive 20? positive 4. So early in the year, we had this, and I said multiply, and you said, well, this is 5 times x is 5x. 5 times 4 is positive 20. Now we're just going in reverse. That's all factoring is. It's distribution in reverse. So it's almost like we're starting with our answer and saying, well, how did we get there? So the first thing we always do is factor out a GCF, and then I say, what's missing to make the original? So this would be the factored form of this binomial. Okay, look at these two terms. What is the GCF of this and this? Well, start with the coefficients first, 15 and 12. And I always say start with the smaller number. Does 12 divide evenly into 15? No. So let's do this. Let's list the factors of 12. 1, 2, 3, 4, 6, 12. I want the greatest common factor, so I say, does 12 fit into 15? Does it divide evenly to 15? No. Does 6 divide evenly to 15? Nope. How about a 4? Does 4 fit into 15? Nope. How about a 3? Yep. 3 goes into 15. So out of the 15 and the 12, the GCF is a 3, because 3 is the biggest number, the greatest number, that divides evenly into both. Then I look at my variables. Well, he's got 3 a's, a times a times a. He's got 2 a's, a times a. Now I'm going to take as many of those a's out as I can. The only rule is they both got to have it. So someone's going to say, I'm going to take out a to the third, because I'm going to take the most out, right? No, the rule is it's got to be common. In other words, they both got to have it. Does this guy have 3 a's to give? No. So we're always going to be limited by the smaller one. That's why I say it's always going to be the smaller of the exponents for your variables. So out of these two terms, the GCF is 3a squared. But if I want to factor, now we do our parentheses and I say 3a squared times what makes this? Okay, so 3a squared times what mystery thing is going to make this? Well, 3 times what makes 15? 5. And if I've got a squared and I want a cubed, how many more a's do I need? Just 1. Plus comes down. And then 3a squared times what makes this? Well, 3 times what makes 12? 4. A squared. Do I need any more a's to get a squared? No, that's it. So this would be the factored form. Okay, 5 and a 5. What's the biggest number, the greatest thing I could take out of a 5 and a 5? Well, they both have a 5 in common. Then I go to my variable terms. He's got m squared, he's got 1m, m to the 1. Remember, we always take the smallest of the exponents. So the GCF of those two terms is 5m, or 5m to the first power. 5m times what makes 5m squared? Well, I already got the 5, but I need one more m. 5m times what makes 5m? Well, times itself, times 1. We could always check to make sure we got it right. Just multiply it out. What's 5m times m? 5m squared. What is 5m times a positive 1? Positive 5m. And if you get the original, that's how you know you did it correct. Okay, number 4. Look at our coefficients. A negative 20, a 16, and an 8. Okay, we'll start with the smallest one. What are factors of 8? 1, 2, 4, 8. So start with the biggest one. Does 8 fit into all of these? Does 8 divide evenly to all of them? Well, of course it divides into 8. It's one of the factors. Yep, goes into 16. Does 8 divide into 20? No. Then you go down the list. How about a 4? Of course it goes in there. It's one of the factors. Does 4 go into 16? Yes. Does 4 go into 20? Absolutely. So out of those coefficients, my GCF would be a 4. How about the variables now? He's got 4 x's, he's got 3 x's, he's got 1 x. Remember, we're always limited by the smallest one. So out of those, 4, 3, and 1, who is the smallest? X to the 1. So I can only take out one of those x's. And normally we don't like having our leading term be negative, so this isn't absolutely necessary, but I'm going to take a negative out. And we remember when we factor out a negative, what happens to all these signs? They're all going to flip. So let's think about this. 4 times what makes 20? 4 times 5. And if I've got x to the 1, how many more x's do I need to make x to the 4th? I need 3 more x's. Notice because I had this negative changed to a positive. Because what is negative 4 times positive 5? Negative 20. So this sign's going to flip. So it's going to become a negative. Don't have to worry about the signs anymore. 4 times what makes 16? 4. X times what makes x cubed? X squared. And this is going to become a negative since I factored out a negative number. 4 times what makes 8? 2. Do I need any more x's? Nope, I already got it. So that's it. Okay, 2 more. Look at your coefficients. 8, 6, 10. So I always start with the smallest number. What are the factors of 6? 1, 2, 3, 6. Okay, start with the biggest one. Does 6 fit into all of them? Nope, doesn't go in 8, doesn't go into 10. How about a 3? No, that's not going to work. How about a 2? Well, since these are all even numbers, a 2 will fit into all of them, or divide evenly in. And how about the variables? He's got 2 p's, he's got 1, so right now I can take out 1, but does he have a p? No. Remember, they all need to have it in order to be considered a factor, a common factor. So right now, the GCF is just a plain old 2. 2 times what makes 8p squared? Well, 2 times 4 makes 8, and I need the 2 p's. Plus sign comes down. 2 times what makes 6p? Well, 2 times 3, and I need the p. And finally, 2 times what is going to make negative 10. The negative comes down. 2 times what makes 10? 5. And last one. What's the GCF of a 20, a 25, and a 15? Well, start with the small one. Factors of 15, 1, 3, 5, 15. So does 15 divide into all those 3 numbers? This one, and this one? No. How about a 5? Yes. Now what are the most x's I can take out? He's got 4, he's got 3, he's got 2. How much do they all have in common? What's the most I can take out of everything? Remember, it's always the smallest of the exponents. So the most I can take out is x squared. So my GCF is 5x squared. 5x squared times what mystery term makes this? Well, 5 times 4 makes 20. How many more x's do I need? If I've got 2 and I need 4, I need 2 more. Negative comes down. 5x squared times what makes negative 25x cubed? Well, 5 times 5 makes 25, and I need 1 more x. Negative sign comes down. 5x squared times what makes negative 15x squared? Well, 5 times 3 makes 15, and I've already got the x squared, so I don't need that. So that's it. Okay, so 6 problems for homework for Factoring Review Day 1. So do those just like we did above, and just like always, take a picture, upload it to Google Classroom, and I will see you tomorrow. Have a great day.